IODA provides the ability to view outages at the country, region, and operator or AS level. Some large outage events can be visible at all three. As a case study of such an outage, let's revisit the daily shutdown in Iran that began in September 2022 in the wake of the death of Masa Amini at the hands of the morality police. Let's look at Iran. Here we've already navigated to Iran signals. And let's select a time range from September 15th to October 15th. So here we can clearly see disruptions in our green BGP signal. Let's turn off the other signals so we can isolate BGP. Remember, this signal is usually quite stable just by the nature of these network announcements. It usually stays around 100%. So seeing these repeated dips and recoveries, matching the reporting from inside the country of the nightly shutdowns or digital curfews, we can be confident that what IODA is showing us in this green signal is the nightly curfews or shutdowns of the three largest mobile networks in Iran. If we turn the active probing signal on, we can see that, so let's consider these days, Sunday and Monday, the 18th and the 19th, as a more normal view of active probing where we hit this maximum around 100% and it then falls down during the nighttime, which is normal, and comes back up during the day. So what we see when BGP drops is this similar kind of decay in active probing where it's not maintaining that maximum that it normally does at this time of day. So it's not as easy to see in BGP, but again, you can see where this abnormal drop during the BGP disruption is not normal. And we can also see if we add our other signals back. Let's do it one at a time. Just adding the Google signal back, where again, during these disruptions, reaching a lower maximum than we did in the days before. So this just goes to show that it's important to look at patterns during a normal internet time frame and see what's happening in this time frame where we know that there was potentially a disruption. So indeed, all of these dips in BGP, active probing, and Google Web Search line up with the daily shutdowns experienced by Iranians. Scrolling down, we can see a map of Iran to see what IODA picked up as the most affected regions, or in this case, provinces in Iran. We can see from the map that the shutdowns really affected all of Iran because these were the three largest mobile networks that were being shut down, with Kurdistan registering as the highest outage score. Please note that these outage scores, as I've said previously, are meant to help guide you to find outages, but they're not a perfect measure, so use this with caution. So let's take a look at Tehran. By clicking this region, we will navigate to the dashboard for Tehran. So now you can see that we're looking at internet connectivity for Tehran. And sure enough, we see a very similar pattern to what we saw at the country level in Iran. So we see BGP dipping and showing that daily digital curfew at the province level, just like we saw at the country level. You'll notice that the Google traffic signal is no longer available, and that's because right now Google traffic data is only available at the country level. But at the subnational level, you'll see that these three active probing, BGP, and telescope signals. So as I mentioned, we know that the Iranian government limited access to the internet during these times by shutting down the three largest mobile internet providers, Irancell, Ritel, and MCCI. IODA does not always have the best visibility into cellular networks, but let's take a look at Ritel. We can look for it by scrolling down to the table of Iranian operators that experienced outages during the September to October timeframe that we selected. So scrolling down, we see Ritel right here. So let's click on it. Now we're looking at the connectivity signals at the network level, in this case, Ritel. Here again, we can see the same patterns of disruption in BGP, these more dramatic dips that line up with what we saw at the Tehran province level and the Iran country level. We don't see a similar daily pattern in active probing. We see something at the beginning, but we just don't see it as clearly. And this again is likely due to IODA not having the best visibility into cellular networks. But we can see that it's kind of harder to interpret, but telescope basically zeroes out when BGP makes these big dips. So if we turn active probing off, we could likely focus on that better. So when BGP comes down to 50%, we see that the telescope signal drops to 0. And then it starts picking back up. And then again, when BGP drops down, it goes to 0. So this shows us that we can see this digital curfew at the country, province, or region and network level in IODA.